Hi everyone, my name is Ming Tse Chen. In this video, I will walk you through my Jupyter notebook titled Crash Course in Causality, where I explore causal effects in the world happiness dataset. I start with the introduction to causality. Causality is more than just correlation. It's about understanding the actual impact of one variable on another. In this project, I aim to estimate how GDP and social support affect happiness. As you can see in the first cell, I define the research questions and introduce the key variables like here. Happiness score, GDP per capita, social support, and others. These are social economic indicators I'll analyze throughout this notebook. So, in this section, data preparation for causal analysis. I prepared the dataset for causal analysis. I first import necessary libraries like pandas, Cibon, and stats models. Then I load and inspect the world happiness dataset. I drop missing values, handle infinite values, and convert the year column to date time format. You will see that I print out the cleaned data frame to check that everything looks right. Visual aids in this part include a correlation, heat map, and some histograms. I think it's down here. Here. Yeah, correlation, heat map, and some histograms. This helped me explore the distribution of key variables and look for multi-collinearity. Here's the heat map. And now for the third part, causal effect of GDP on happiness. So I dived into the causal effect of GDP on happiness. I start with a simple linear regression using only GDP per capita to predict happiness score. The result is what I call the naive estimate. Next, I control for where? Hold on. Next, I control for co-founders like social support, freedom, corruption, and health. This gives me the adjusted estimate, which is more reliable. And I also compare both coefficients to show how co-founding can bias the results. This is followed by a visual, a box plot showing happiness scores for high versus low GDP countries. And for this part of matching method, I used a matching method to estimate the causal effect of GDP. I create a binary treatment variable, high GDP versus low GDP based on the median. I then standardize the covariates and perform nearest neighbor matching. For each low GDP country, I find a high GDP country with similar social support, freedom, health, and corruption. The average treatment effect from matching is printed and compared to the naive difference in means. I also include a box plot to visually show the impact of GDP on happiness. And the 3.4 part, propensity score method. So in this part, I used propensity scores to balance the treated and control groups. I fit a logistic regression model to estimate the probability of being in the high GDP group. You will see a histogram showing the distribution of propensity scores for both high and low GDP groups. If the two distributions overlaps well, it means the groups are balanced. Then I applied inverse probability weighting to estimate the average treatment effect. The final result is printed and compared to earlier estimates. Now I shift to analyzing the casual effect of social support. I define high versus low social support and use similar methods, regression and nearest neighbor matching. The regression model includes covariates like GDP, health, and freedom. I show the model summary and explain the coefficient for high social support. Again, I use matching to estimate the treatment effect. The box plot here shows how happiness varies with social support. In the fifth section, I simulate the effect of unmeasured confounders. I create a random variable and make it related to GDP. Then I add this confounder into the happiness score to create a confounded outcome. I rerun the regression and show how the estimate of GDP's effect changes. The side-by-side box plot, one for original data and one for confounded data, visually highlight how hidden variables can distort causal conclusions. And finally, I conduct a temporal analysis. I look at how average happiness, GDP, social support, and freedom change over time from 2015 to 2018. Each subplot tracks one variable across years. Then I calculate the causal effect of GDP and social support on happiness separately for each year. The final plot shows how these causal effects vary across time. This helps me understand whether the importance of GDP or social support has grown or declined over time. To wrap up, I've shown how proper data preparation and causal inference techniques like matching, regression, and propensity scores can reveal the actual drivers of happiness. Rather than just looking at correlation, I used causal methods to understand how GDP and social support influence happiness and how these effects change over time. This analysis is not only informative but also essential for designing policies that genuinely improve quality of life. Yeah, I think here's also my reference and my MIT license. Yep, that's it. Thank you.